We got this melody, and you can trust me, baby. We got everything. Call me whenever you feel alone, babe. And when you need to cry, I'll be by your side. Call me whenever you need someone, babe. And when you need to escape from 1,000 fires, I'm gonna kiss you wherever you are. And I'm gonna miss you, I will never lie. Call me whenever you need someone, babe. We're running in the jungle of love. Jungle of love. We're running in the jungle of love. Listen to my conditions, I got you on my mind. You were stuck in my head and I don't know why. We got a billion reasons, we got this melody. And you can trust me, baby, we got everything. Call me whenever you feel alone, babe. And when you need to cry, I'll be by your side. Call me whenever you need someone, babe. And when you need to escape from 1,000 fires, I'm gonna kiss you wherever you are. And I'm gonna miss you, I will never lie. Call me whenever you need someone, babe. We're running in the jungle of love.
Good evening and welcome everybody. This is Obi-Wan Pez for N Simplex Pachinko, and we are doing some math content tonight. Today is our first chapter review for cracking the GRE math test. And this means that not only are we going to do the math itself, but also we're going to show like how to get by in an exam, which is not like my favorite thing. But if you're gonna take standardized tests, you might as well learn also how to take them. This is really bright. There we go. That's better. That's more like what it used to be. Okay, so what was I going to do? We're going to, first of all, reset the canvas. And turn down the music a little bit. As much fun as it is. 55? Yeah. I know some people on YouTube have given me a little bit of crap for having annoying music far too loud. Okay. So for the Chapter 1 review, we have find the sum of the solutions to the following equation. Square root of x minus 1 plus the square root of 2x minus 1 is equal to x. Alright, so most of the time when they're doing stuff like this, the solutions here are going to be probably whole numbers. They don't always have to be. It could be like a half, for example, in the first one, which could get us, in this case, a 0. We do see, however, on the other one, a half is going to get us a negative value. So, well, first of all, if that is a imaginary number with a negative inside the square root, and this is a 0, then our x value would have to be a complex number, but we had a half. So we're going to try to plug in real numbers only to this, and it should in fact say like find the sum of the real roots of the following equation or something like that. But sort of the quick and dirty way to that's not true. The nicer way of looking at this would be to say like, okay, first of all, what's our domain? You don't even have to necessarily do this as like a formal thing. Just in the back of your mind, you should be thinking, okay, the stuff on the inside of the square root should be non-negative. So x minus 1 should be greater than or equal to 0, and also 2x minus 1 should be greater than or equal to 0. This means that x is greater than or equal to 1, and... It's Zach! Love that half second of panic. Right, so here we have x needs to be both greater than 1 and also greater than or equal to a half. Therefore, x should be greater than or equal to 1 as a domain. So this should be the numbers that we're actually looking for. Again, we don't know what the solutions are at the moment, but at the very least, that's where we're looking. And a happy Monday to you. I started really late. It's so hot. In that our location, you know, our condo does not have air conditioning, and it was 87 at some point today, so yay. It's like the good old days. I mean, quite honestly, it's like I was back in New Hampshire, because like we had a window box unit, and we would stick it in there for like, you know, 2 weeks out of the year. My brother and I would sleep downstairs on the couch. Yes, so our year mark was in April. I didn't make a big deal of it, but I mentioned it here and there. Yeah. Oh, no worries. Thank you. Yes, we have been surviving quite well. Every so often, one or the other of the kids will be like, I really miss Maryland, miss home, you know, whatever, but... Hey, Slayer Darth. I mean, if you have any other questions, I will be happy to answer them. It's just that a lot of people did not have any other questions, so I was like, right. Hey, Viv. Okay. So the official math way of doing this would be to say we want to take our square root equations and end up squaring both sides so that we get a one of the square roots gone. So, or at maximum, we want one square root term. So here, I typically move one or the other of them over to the other side. I'd probably say the one with the single x in it here. So we get a square root of 2x minus 1 is equal to x minus square root of x minus 1. And then square both sides, so we get 2x minus 1 is equal to x squared minus 2x times the square root of x minus 1 plus x minus 1. Right, that's our square root squared when we do that. So now we look at this and say, let's shift everything around a bit. It doesn't really matter which way we go, but if we keep the right side with our x squared, right, we can, oops, let's back that off, minus 2x plus 1 and plus 2x root x minus 1. So we have minus 2x plus 1 and a plus 2x root x minus 1. Goodness. Is this like SAT or GRE? And obviously not math, but anyway. GRE verbal reasoning. Yeah, all right. I mean, you're not wrong. 2x root x minus 1 is equal to, so here we get x squared. This one's all gone here, this stuff is all gone there, and then we get an x minus 2x is minus x, and minus 1 plus 1 is going to be 0. So that's nice. Okay. So this is interesting, right? If x equals 0, then we've got 0 times the square root of negative 1 is equal to 0. Now, I will grant you that that works 100% of the time here. However, I think if we... yeah, if we look back at the original, this does not work. So we have the square root of negative 1 plus the square root of negative 1 is equal to 0. So this does not work here, which means that x cannot be equal to 0, which does mean that we can say that we can divide an x from all of our terms without having to worry about losing a potential solution. The other option is, like, if this was a viable solution, one of the things that we could say is, oh look, we could... yeah, the other fun thing about this is, up top it says, find the sum of the solutions to the following. So even if 0 was a real solution, it doesn't matter, because we're just adding up all the sum, or the sum of all of the solutions, and 0 doesn't do anything. So we could also assume, right, x is not equal to 0, therefore we can divide through by x. So this is going to be 2 square root of x minus 1 is equal to x minus 1. Interesting. Other option, this does mean that we could potentially divide by the square root of x minus 1 and get only one x minus 1 term. But this is a very specific case where it worked out very nicely. In general, we'd want to take both sides and square it again. You can move around the 2 if you wanted to. I prefer to keep it just as is, so that we get all that together. This is 4 times x minus 1 equals x squared minus 2x plus 1. This is going to be 4x minus 4, x squared minus 2x plus 1, minus 4x plus 4 is going to be 0 equals x squared minus 6x plus 5. This is going to have two solutions. The solutions must have the same sign, and when we factor it, both of them are going to have negative signs within the factorization, because here we're going to have the sign of the larger number, right? The sum of these two is going to be negative, and then also, since this is positive, they have to be the same. They have to have the same sign. So here we could do, oh no, does it work? Right, both of them have to be negative, and yeah, this adds up to negative 6, so we can split it as x squared minus x minus 5x plus 5. Who has time for this, right? Is going to be x times x minus 1 minus 1 times x minus 1. Nope, minus 5. Sorry. Take out a negative 5 and leave behind x minus 1, which now leaves equals 0. X minus 1, x minus 5. Sure, you didn't have to go through all that. You probably knew that already just from trinomial factoring. Super simple, right? No worries. And then here, this is x minus 1 equals 0, or x minus 5 equals 0. So therefore, x is going to be either 1 or 5. And then we have to go back and check. So the question is, right, is this going to be 1, 5, or 6? Or potentially 0, if none of them work. So we go back to the beginning and we say, nope. Take the original question, copy, paste it down at the bottom. Right. And we say x equals 1 is going to mean that we get a 1 minus 1 is 0, plus 2 times 1, right? Yeah. 2 times 1 is 2, minus 1 is 1. So we get a square root is 1 is 1. So yes, 1 works. If x is equal to 5, we get square root of 5 minus 1 is 4, square root of 4, which is 2, plus square root of 2 times 5 is 10, minus 1 is 9, square root is 3, is equal to 5. Hey, look at that. Pretty cool. So the sum here is going to be 6. And in our, I didn't actually post what the possible solutions were, but it was A is 1, B is 2, C is 4, D is 5, and E is 6. So we do get E, option E, if anyone is following along with a book from 2002. Okay, now, quick and dirty. How do we do this? Because we're in a standardized test and we don't have time for this. Okay, option 1, graphing. Okay, square root plus square root equals x. This was x minus 1 and 2x minus 1. Oops. Okay, well, that worked. No, I shouldn't have done it that way. Hang on. Okay, so we get you know, y equals this and y equals x. Figure out where they end up meeting up. So here we have an intersection point at 1, 1, and here we have an intersection point at 5, 5. Again, just double check to make sure that both of these things exist at those points. So if you've selected green on this thing, right, then you're going to end up with it exists everywhere because it's y equals x. So no biggie. If you have selected blue, this is where you have to be careful. So 1, do we get a number at 5 comma blank, right? Because this could say 5 comma undefined if it didn't exist here. Alternatively, do the same on the other end. So 1 comma 1 instead of 1 comma undefined. So cool. It works. We get 1 comma 1, 5 comma 5. So therefore, both of those x values work. 5 plus 1 is 6. Answer is E. Done. So if you have a TI calculator, you need to post both of these in your y1 and y2, and then try to find the intersection. And then when you hit intersection, it's going to ask you for left and right bounds. Actually, it won't. It'll ask you which equations do you want to find the intersection for. So y1, y2 being these two things, and then enter a guess. Put something that's close to one of the answers, and it'll get that number. You can manually type it in. So if you type in like 1, because I think it's near 1, it'll spit out 1 comma 1. If you hit, well, it looks around 5, 5, it'll spit out 5 comma 5. There is the potential that because this is a numerical analysis rather than like a strict because it's numerical analysis rather than a strict like symbolic solution like we did, it could come out with something like, you know, x equals 0.9999999999998 and y equals something similar. If that's the case, then realistically you think, okay, well, it's close enough to 1 that that's probably the answer. Actually, it wouldn't do 0.9. It'd be 1.01 or something like that. Because 0.9, etc. will not work in this particular context. So basically, just look at it, and then you can also double check the answer by just plugging it in. Use your head, right? Just does it come out to nice answers? If we ended up with like 3 as an answer, and this ends up with 3 minus 1 is the square root of 2, plus, right, 6 minus 1 is 5, the square root of 5. You've got 2 different square roots which are being added together. You're not going to get a rational number, so there's no way ever that you could end up with a 3 on the other side. So you'd know that is an extraneous solution. You could just toss it. Similarly here, we also found that 0 was an extraneous solution. Right? 0 could, in theory, work as a solution if we say that this is going to be 0i equals 0. It's true. It just doesn't work for our broader, the broader implications of this problem. Okay. Why don't we move the 4x minus 4 to the other side directly instead of writing it down? I mean, you can. So this is the teacher me, which is just, I'm just like doing out every single step to show you how to make sure every little bit is being moved around. People often wonder why I was selected to be the treasurer of our Parents and Friends Association at school. That might be why. Right? I'm pretty decent at accounting for all sorts of little things. So okay. But yeah, like I said, you could just as easily toss that around and choose differently. I already did this. What is going on? That is not actually a problem. What is your issue? Sorry. This is a completely different... I would like the computer to check again. That's weird. Okay, no. It's fine. My channel point is like called simplices because we were talking about well, I mean, n simplex pachinko, but we were also like discussing multi-dimensional a fake multi-dimensional pachinko machine that kind of has like balls that are moving in an nth dimension, which really physically only works out to 3, but you know, you could pretend if you look deeper into it. What percentage of people in the world are drunk at any given time? Oof. But I just uploaded a so I had commissioned one from our engineering department, and allegedly he made it, and I was like, you know, I need to give you money so that I can get it, and like he may not have actually made it. But whatever. But yeah, I can make one. I just have to figure out how to do it. And I mean, the one he made was like $200, so that's like 130, 170 pounds here, depending on what materials and stuff. I think he had done it mostly with copper. And then if you're using glass marbles to go through or steel ball bearings, could be interesting. It'd be very loud. Alright, so if you're doing this on a standardized test, again, graphing is a good way to do this. Just find out where the intersection points are, and then go and plug in the numbers to make sure that they work. And then, again, the trap here is that you have 1 and 5 as your solutions, and you may not remember, oh, I need to find the sum of the solutions. So 1 plus 5 is 6. Honestly, there are multiple traps. There is also, in some cases, the possibility that one of these solutions will be will get you the opposite sign of what should be here. So, for instance, when we plugged in 5, right, we got 3 plus 2, or 2 plus 3. There is the possibility that if you plug it in, obviously in this case it didn't do that, but this could be -2 plus 3 would get you your 1. Or 2 minus 3 would get you a -1 if, like, you plugged in -1 as your x value. But here we see that the square roots are being added together, not subtracted in any way. So it is possible that you could run into something where it would be true if one or the other or both of your square roots had the opposite sign. So that's just something else that comes up if you've seen it before, you'd recognize it. Okay, Determine the set of positive values of x. 2. That satisfy the following. Uh, 1 over x minus 1 over x minus 1 is greater than 1 over x minus 2. Okay, actually, let me write down the possible solutions first, right? So, A is 0 to 1 exclusive, union with exclusive root 2 to 2. Yeah. B is 0 to 1 union. Nope. 0 to 1/2. Union 1 to 2. C is 1/2 to 1. Union 1 to 2 root 2. D is 0 to root 2. Union 3/2 to 2. And E is 1 to root 2 union 2 to 2 root 2. Okay, so think about those in the context of what we're doing. Again, I'm going to show you like the official way to go through it mathematically, and then we'll look at the quick and dirty way to make sure that we can do it on a standardized test quickly. So what we're looking at here is that we have our LCD, which we want to multiply through everything by, and it'll make it so much easier in order to yeah, it'll make it easier to solve the inequality if we can figure out what the least common denominator of the whole thing is. Basically, we need to take all of our terms and find the lowest common denominator is going to be your least common multiple. So it's x times x minus 1 doesn't share any factors with x that we know of. And then x minus 2 doesn't share any factors that we know of. If x is an even number, then x minus 2 is also even. So potentially they share a 2 as a factor. But again, we don't know. They could also be odd numbers, x and x minus 2, which then means that their least common multiple ends up using both of them, both of those numbers entirely. But in general, this is what we've got. Our least common denominator, least common multiple, is going to be x times x minus 1 times x minus 2. And if we multiply all the way across, and if we pretend that this is an equation, it's totally an equation, then we end up with x times x minus 1 times x minus 2 all over x. Minus, we're going to need more room. Should have seen that one coming. Okay. X times x minus 1 times x minus 2 over x minus 1 is totally equal to x times x minus 1 times x minus 2 over x minus 2. Then we take our x and we divide out from here. We take x minus 1, divide out from here, and x minus 2, divide out from here. This means that we have left x squared minus 3x plus 2 as our first one, minus parentheses, x squared minus 2x is totally equal to x squared minus x. Okay. Then if we look at all of this, we end up having, right, this is x squared minus 3x plus 2 minus x squared plus 2x is equal to x squared minus x. Okay, so our x squared and minus x squared are going to add to 0. Our minus 3x and plus 2x are going to add together to get us a negative x. And what we can do at this point is add stuff to both sides in order to get our x squared term as a positive number, because I prefer that way. It doesn't have to be. You can go either way, but I think it makes it a bit easier. So here we can do plus x minus 2 gets us a plus x here and a minus 2 here. And honestly, we could have left the 2 on the other side, because that's going to get rid of our x term, it's going to leave our x squared term, and it's going to leave our constant term of 2 on the other side is fine. All right, so 2 is totally equal to x squared. And this says that x is equal to plus or minus the square root of 2. Now, what does it really mean? Like, what am I doing here? These are all of the points where our original inequality would have been 0. Or, sorry, where the original inequality would have been equal. So here, our plus or minus square root of 2, if we go back to the beginning, if I plug in the square root of 2 into all 3 of those x's, and then worked out all of those nasty complex or irrational numbers, if I rationalize the denominators, do all this other stuff, then we would find that either the positive or negative square root of 2 would get us equal things on either side. And sure, why not, right? Let's just plug it in real fast. Okay. We could do it this way too. Right, 1 over x plus minus 1 over x minus 1, and then here 1 over x minus 2. Right? Where are these things equal to each other? 1.414 and negative 1.414. Oh, look at that. Right? Of course they are. These are where they're equal to each other. We just worked that out mathematically. And again, here we can look at it graphically to say, here's where they intersect each other. So what I would do is I would construct a number line and say, where are the possible places that our inequality could change from being less than to being greater than, or vice versa? So we have negative root 2, positive root 2. These are places where they're equal to 0. So here, they could change from one to the other. And in fact, since our roots here have each a multiplicity of 1, we know that it is actually going to pass through that particular point if you zoom in really close, locally, it's going to look like two linear functions. So they're going to look like they cross each other like two linear functions. They're not linear functions, but again, if you zoom in real close, it kind of looks like it. We'll look at that in a second. Okay, where else could we end up crossing each other? Well, our intermediate value function, if you go to calculus, and we talk about this a little bit in pre-calc too. If you look at the intermediate value function, what that says is if you have like a positive number and a negative number, and it's a continuous function, then there must be a 0 somewhere in between. Or in this case, right, if we pick a number here and a number here, and it's a continuous function, then these two things must go through every single value in between. Your y value here and your y value here, whatever they are. If it's a continuous function. So now we look at this and say, that means that if we have a discontinuity, then we could end up swapping again. We could end up losing our inequality being the same way. So here we say, okay, what if the least common denominator here, what if any of those individual things in the denominator are equal to 0? That will create a problem. That will create a discontinuity. So we look at discontinuities and say, when the LCD is equal to 0, then we end up having these discontinuities. So x cannot be 0, 1, or 2. On here, that's 0, 1, and 2. Hashtag not to scale. Okay, now what we do is we say we're going to pick test values. So in between all of these numbers, we're going to pick a number which is going to be representative of that entire area, because our function can't cross at any other point and also can't have another discontinuity that we didn't already write down. So if we pick another value, let's say this is -2, this is -1, this is a half, this is 1.3, this is again 1.7, and then out here is 3. Right? Now we have represented all of these individual intervals. So now we could just plug it into the calculator. It's fine. Right? So what we do is we say, okay, what's our left side going to be? What's our right side going to be? What do we get in total? So with -2, right, this is going to be 1 over -2 is -1/2, minus 1 over -2 minus 1 is -1/3. So what is -1/2 minus negative, so plus 1/3? That's going to be -1/6. So that is again, I would do this in the calculator, especially since we're doing this on like an exam. You don't want to take super amount of time doing this. And then -2 on the other side is 1 over -2 minus 2 is -4. So -1/4. And this is true, right? -1/6 is more positive than -1/4. So this is true, which means that everything from -√2 out toward -infinity is going to be part of our solution set. Without doing anything else, That's going to be a problem. Oops. Did I screw that up? I mean, I must have, right? Uh-oh. Alright. Alright, so negative 2. Negative 2. We end up with... Yeah. Yeah. Right? Negative 1/6 is greater than negative 1/4. I mean, it's possible that it's a misprint, but also... Oh. Read the question again. Determine the set of positive values x that satisfy the following. So, again, read the question. Okay. For completeness, let's look at negative 1. Right? So if we plug in negative 1, we get 1 over negative 1 is negative 1, minus 1 over negative 1 minus negative 1 is going to be, or negative 1 minus 1. It's negative 2. Switch it is positive a half. So negative 1 plus a half is going to be negative a half is greater than. Negative 1 is 1 over negative 3. So negative 1/3 is... Negative 1/2 is greater than negative 1/3, which is false. So the region containing negative 1 is not part of our solution. Okay. A half is going to end up with 1 over half is 2, minus half minus 1 is negative a half, becomes negative 2, we're subtracting, so 2 minus negative a half is going to end up being 4, is greater than, this is a half minus 2 is negative 3/2, or flip it over is negative 2/3. So 4 is greater than negative 2/3 is true. And we can't have this be equal to 0 because 0 is a discontinuity, and 1 is also a discontinuity, but anywhere in between we can pick x values which are going to be correct for that. Okay, so now this becomes part of our solution set. So from 0 to 1. So looking at our solutions here, we have only from 0 to a half. Well, a half was our test value, but like we could have plugged in something else. There was no reason to get 1/2 anywhere in this entire problem. So we don't have any reason to pick B at all. C is missing those values from 0 to a half. So again, we're going to eliminate that one. There is a discontinuity at 1, so we can't pick D. And E, again, we just found out that from 0 to 1 is perfectly acceptable, so that's missing all that stuff. So just doing the one test value, right? Just doing the one test value at x equals a half, we've just shown that we're going to get from 0 to 1, A is the only possible answer. So that actually goes pretty quick. Okay. Mathematically, in order to be, rigorous about this, then we're going to also look at the other stuff. So what about 1.3? If we pick, again, this value over here, 1.3, we see that our purple is underneath the black, And that's a problem because we want to know when the purple function, the left-hand side, is greater than the right-hand side, our black function. When is purple greater than black? When is purple above black? So for x equals 1.3, we end up with purple under black. Purple is less than black. So, don't want that. That's not going to work for us. If you need the numerical values, right, our black function is negative 1.428, whatever. So that's on the right-hand side. And then 1.3 here. On the purple function, our left-hand side is negative 2.56. So is negative 2.56 greater than negative 1.4? And the answer is no. Of course not. So that doesn't work. Until we get to the square root of 2. After which point, right, x equals 1.5. We now have the purple function gets a value of negative 1.33 or negative 4/3. And the black function has a value of negative 2. So is negative 4/3 greater than negative 2? Yes. Also, the purple function is above the black function at that particular x value. So therefore, it satisfies our inequality. The section that contains 1.5 or 1.7, because that's the actual number I picked, does work. And again, we can't have the value at the square root of 2 because they are equal to each other, and we don't want to know when they're equal. We want to know when the one is actually just greater, strictly greater than the other. And we have a discontinuity at 2, so you can't plug 2 in. And speaking of which, right, after 2, right, this function, our purple function, has an actual value of negative 0.5, but our black function is undefined. This is an asymptote. So x equals 2 is undefined for black. But then, anywhere after that, we have these big positive numbers, and then they shrink down. They're still going to be positive. They will remain positive as far as we want to go out. Our purple function, as we get bigger and bigger and bigger numbers, we have 1 over x minus 1 over x minus 1. So our denominator ends up being ever so slightly, ever so slightly smaller. I'm having a moment, hang on. Right. So as we get really, really big, this is going to be like 1/10 minus 1/9. It's going to be positive, but not by much.
Rating party!
It's a rating party. Good evening and welcome, Academy of Useless Ideas and the rest of the gang from over there. How are you all doing this evening? My name's Obi-Wan Pez. This is N-Simplex Pachinko, and tonight we are working on discussing the cracking the GRE math test. We are currently working on Chapter 1 review questions. So I am doing both the mathematically rigorous way to do it. Descend d'enfant, how's it going? So it's the specifically math test, but yeah, it's the like general GRE math test, not the like, or wait, hang on. I think this is the one that math graduates actually take. So additional topics at the end do include set theory, combinatorics, probability statistics, point set topology, real analysis, and complex variables. It mostly goes through, let's see. All right, so the super headings are pre-calculus, which we're just finishing. Calculus 1, Calculus 2, differential equations, linear algebra, Part A, number theory, and Part B, abstract algebra, and then the additional topics, as said before. Femvox, yeah. Yep, math subject. The 2002 edition? Nice. Go to the abstract algebra section. I mean... right, we do talk about here, we're saying like, number one, we're going to do the mathematically rigorous sort of way to do it, and then number two, we're also going to go through like the quick and dirty way to do it. Most of which, because this is the pre-calculus section, is going to be just graphing it. Woohoo! So in the last one, that's pretty much what we did, right? We graphed it and figured out some decent values to make it work. Okay, solve for x. Ads are going to come out in about 2.5 minutes. You know what? I'm going to snooze that. That's fine. Since y'all just got here, right? It doesn't make any sense to make you sit through ads immediately. All right, so solve for x. Absolute value x plus 1 minus the absolute value of x plus 2 times the absolute value of x minus 1 is equal to 2x minus 1. Okay, so the answers, so that we can kind of be formulating an idea, are going to be either x is equal to negative a half or 1, b, x equals negative a half or 2, c, x equals 1 or 2, d, x equals negative 1/2, 1, or 2, and e, x is greater than or equal to 1. Solve for x. Haven't seen that in a long time. Yeah. Wonder how much the GRE has changed. Yeah. Learn how to solve the problems a little fast. Yep. 20 extra minutes. Test to be solvable. You know, 800 or something. Yeah. Right. So, this is nasty, a little. So what we have here is a failure to communicate. So what we have here is that we have 3 absolute values where these things can change the sign of the inside stuff at each of the places where they individually turn 0. So there's kind of like 2 ways that we can look at this. One is that we want to algebraically, this is a little rough. We'd want to look at like where each of these things is going to be positive or negative. Positive or negative. and then determine what its behavior is for each of these sections. So it's a bit rough, but at the same time, it's not horrible. So like this is going to be x. This is going to be x plus 1 for x greater than or equal to -1, and negative x plus 1 when x is less than -1. Right? This one is going to be x when x is greater than or equal to 0, or negative x when x is less than 0. And this is going to be x minus 1 when x is greater than or equal to 1, and negative parentheses x minus 1 when x is less than 1. So like I said, gets to be a little rough, but at the same time, it's not like, it's not awful. And we can figure it out easily enough. We could also just say, all right, look, if we have the extreme cases where we have just negative x plus 1 minus negative x plus 2 times negative x minus 1 is equal to 2x minus 1. So this is when x is less than -1. All three of them are true in the negative direction. Right? I'm not saying this is the best way to do it, but I'm just saying, like, can we come up with a reasonable answer in a short-ish amount of time that is mathematically rigorous, that we can, you know, figure this part out? Let's snooze that again. Okay, so this is going to be a negative x minus 1 plus x minus 2x plus 2 is equal to 2x minus 1. Again, x has to be less than -1. Here we get that negative x plus x is gone, and that's it there. Okay. Then we get a -1 and a plus 2. So this is negative 2x plus 1 is equal to 2x minus 1. Those are opposites of each other. X is less than -1. Add 2x and add 1. So this is 4x is equal to 2. So x is equal to 1/2. So if x is equal to 1/2 while x is less than -1, we have a false statement. That is a no solution there. Okay, so as you can see, this is going to get a little involved. Again, we could figure out what's going to happen if all of them are positive, and then we have to like flip each one. Again, to do it a little bit faster but still retain mathematical rigor, we could also say what's going to happen in each of these individual sections. We could almost do it as like a inequality and see where we might get solutions. That might be a little too ridiculous. I don't know. Now I'm curious. I'm kind of curious if that's even going to remotely work, honestly. I mean, the easy way to do this, again, is just going to graph. We're going to come through and just say, all right, let's graph it. So if we get the, nope, if we get the absolute value of x plus 1 minus absolute value of x, right, right, plus absolute value x minus 1 is equal to 2x minus 1. This looks like we have only one solution. Right. Since we had an equation here, we can also eliminate the inequality as an answer, because it's not going to be a solution forever. Oh, no, actually, it could be, potentially. I'm wrong. It could be because if they coincide with each other, then you could eventually, you could eventually end up having coincident lines. That's actually true, right? Okay. I forgot the 2. What do you know? The thing I tried to eliminate. Do you get Desmos for the GRE? No. You do, however, get your calculator, usually. At least not as far as I know. Yeah, that's also true, is try to add the slopes of the lines and then determine what's going to happen when. Try out the x's. Yeah, I mean, that's also the other thing. True. Yep. Yeah. Being too rigorous is, in fact, a time sink. And in this case, again, looking for kind of the easy thing and saying, okay, can I get a 2 here in terms of the slope? You know, the answer is yes, right? If all 3 of them are positive, then we end up with a positive x, a minus x, and a positive 2x. So we end up with the same slopes as each other, get the slope of positive 1, and then, again, if we just add them all up, we get add up all of the constants. We get a plus 1 and a minus 2, which adds to a minus 1. So we do get 2x minus 1. And so, yeah, the answer is actually the thing that I tried to eliminate. X is greater than or equal to 1. And true, you can plug in each of these values. Again, if you plug them in, like, just on the calculator or whatever, most of them, you could do it in your head pretty easily, right? So 1 is going to get you a 2, minus a 1 is a 1, and a 1 here is a 0. So, yeah, plug in 1, you end up with a 1 equals, and this would be 2 minus 1 is 1. So the answer of 1 is correct in some way, shape, or form. And then 2, you get 2 plus 1 is going to be 3, minus 2 is going to be 1, plus 2 times 2 is 4, so that's going to be a 5. 6 minus 1 is 5. So 2 is also a correct answer. And then you do, okay, what about 3? Plug in 3 and see if that works. All right, ads are going to start. Sorry about that. Going to go grab a drink. Everybody stretch, get up, do stuff. Be back in 3.
Find all of the songs of the summer in one playlist. Summer Hits 2025. Featuring hits from Rosé and Bruno Mars. Clean Bandit. Fred Again. Ed Sheeran. And more. Listen on Spotify.
There's more to Spotify than meets the ear. That's because video is taking center stage on Spotify. With over 300,000 video shows and 300 million users already watching their favorite podcast. With seamless switching between watching and listening, you can tune in anytime, anywhere. Got a show of your own? Upload your video to Spotify, turn views into fans, and monetize your passion.
Right, and Academy's true here, or speaking the truth. Certainly, if you like failed the GRE, they're just going to be like, nah, we don't want you in this program. But if it was like you passed, but at the same time your like intended field you did poorly in, they might be like, that's kind of weird. Like, why do you want to go into differential equations if you failed the differential equations section? You know, like Academy said, though, there's a good chance they'll never see it, just because who's going to care that much? Your advisor individually might take an interest. But I also entered a applied math program. Whoa, that's sour. Whew. Tonight is hashtag not sponsored by Wiper and True's Happy Hour Pineapple Margarita Ghost. Well, that's going to be interesting. So anyway, I entered a program which was at the Johns Hopkins Applied Physics Lab, and like basically as long as you keep paying the bills, they don't care, and you're only allowed to have one C at any time. So, you know, as long as you're paying your bills on time and you don't get C's, and you know, their way of checking that you're probably not going to get C's would be to, like, again, clean off anybody who didn't get certain score on GRE. And that is true, right? That a lot of people with good talent might be eliminated just by not having a good GRE score. But what do they need to do? they need to take it again, and they need to study whatever they didn't get last time. So, you know, somebody who is a good talent either can get by without the GRE and like without their particular master's degree. You know, they could probably learn some cool stuff by themselves. They could do some cool stuff just with a bachelor's. They might not be able to get into the particular position or the particular field that they want to. But again, yeah, or just do some research. Or as postgrad, right? You hook yourself up to a research team, and then you can do all sorts of cool stuff. Having to do leak code in a software development job. Yeah. Whew. Alright, before it melts. Anybody who has not seen one of these before, these are digestive biscuits. They're available, especially in Britain. Oh my god. And the chocolate is melting. You're not wrong. And there are some people who use the word cookies. Yeah, but to say, you know, the biscuits are made with, like, you know, flour and buttermilk and things like that. These things are mostly sugar. I mean, yes, by weight, they're mostly flour, but... There is a fundamental difference between biscuits and cookies. Or, if you will, scones, which only have buttermilk in them. Yeah. Yep. I cooked tonight, and I was just like, oh, this is probably a mistake. Like, all I did, I made this really short taco recipe. So, you take, you know, whatever you're making. Usually it's, we make it with tofu. You basically take a tofu brick, and you drain it, and then you just mash it with a potato masher. And then you mix it with all the spices that you get. And then you start cooking it, and you throw on a few more extra spices and salt and pepper and whatever. And then when you're pretty much done cooking it, then you add a can of black beans. And then mix it all up. Toss it in a bowl, and then you just spoon whatever you want on, and then, you know, go get your toppings. We don't really do sour cream, but, like, I'm the only one who actually enjoys it. But, you know, salsa, other vegetables, whatever you feel like. Cheese, yes, cheese. But today it was like, I threw, so I had my cast iron skillet. I threw on the pound of hamburger or whatever. So it, you know, we do a lot of meat here instead of tofu. It's all right, but it's all pretty much locally sourced, so like it's pretty good. So we toss the beef on and just like break it up with a spoon, get it 80% the way cooked, dump on the beans, and then just let it cook the rest of the, or yeah, and dump on the spices as you're cooking. Instead of dumping on the spices while you're mashing it, because it's raw meat, so now we just cook it. And like the stove was on for 10, 15 minutes, and I was just like pouring sweat. I'm just like, ugh, shouldn't have done this. You would probably love living in Argentina. I mean, like right now it wouldn't be too bad because it's winter. But yeah, I know. It is similarly, right, on the opposite end of, on the approximate same latitude. So I grew up in New Hampshire, and that's at 30. Oh, the meat, I see. Yeah, I mean, like, we try to eat less meat, generally. And when we were back in Maryland, we were, like, attempting to eat significantly less. But, yeah, it was alright. What's the latitude there? New Hampshire. So, I have said earlier, right, we are approximately at 54 degrees north. Where I grew up in New Hampshire was approximately 43 degrees north. So like that's a whole extra 10 degrees on the latitude portion of this. And in Maryland, we were living at approximately 39 degrees north. So, like, that actually wasn't that big of a difference, numbers-wise. Right, 39 to 43. New Hampshire is always in the news because we are the first state to vote. There is like one town in New Hampshire which has the distinction of being the first town in the primary elections. Okay. I thought it was pretty good growing up. Looking back on it, I thought it was pretty good. Some downsides, I suppose, is that, like, I was growing up in and around, kind of suburban town, right? It's a town. It's got 20,000 people, give or take. My town was rural and only had 3,000 people in it. Like, there was the possibility we had more cows than people sometimes. We had one, like, humongous farm that was over one of the major hills. You could get there in probably 20 minutes walking. So that was kind of fun. This is where I learned that electric fences hurt. I've always had a problem with electricity, just generally speaking. So, like, I get zapped by something, I'm like... But back then, it was like I would just keep cringing, just being like... Most mathematicians' childhood were in rural... I don't know what that word is Oh, neighborhoods. um, I mean, not always. There's a number of, I mean, proportionally, right? You probably get more people out of suburban rural areas to become, like, per capita than you would in big cities, just because in big cities, like, you've got more people shoved into a small space, and, like, that breeds its own sociological problems. But, like, numbers-wise, you're always going to get more people out of a city that end up becoming scientists, mathematicians, whatever. But, like, is there a per capita percentage disparity? That'd be an interesting case study. So I don't know that your assertion is true, but it'd be an interesting thing to actually look up. Out of my class of 330 people, give or take, we had 60 people who were in Calc 1 in senior year, so our AP Calculus. Of those 60 people, most of them were also in an AP language. Most of them were also in an AP English, history. Most of us were just in Physics 1 for science. Some people ended up pursuing... I guess I was in AP Physics, technically. I forgot. Yeah. I only got 30 minutes left for the GRE to be submitted. Yeah, okay, that's fair. We've been at this for, what, an hour 30, and we've just finished question 3. And we have a beer. This can only go well. There are 12, 23, 25 questions. Puiwika, good evening. Welcome. So, I like where we are. We are in Yorkshire, just as a broad generalization. Technically, there is North, South, and East Yorkshire, maybe West Yorkshire as well, but you could break it down if you wanted to. I don't like to be particularly specific. We are close to Leeds, so ish. There are some rough areas naturally. I like living in the area where we are, where, like, we're in a town. I can get to about 10 to 15 coffee shops by walking. And a number of bars are also coffee shops in the morning. That gets to be fun. You were never in the elitist group? No. So, you do not have to worry about this, like, elite group of kids. Certainly not Premiere. No, I don't even remember. So it's not. I know, like, Leeds United is the, or United. Yeah, Leeds United Football Club is popular, even if they're not our closest football club. Our One of my son's best friends has, like, convinced him that he should like the Reds. Oh, okay. Yeah, our local football club is not in Premier, but yeah, Leeds United is pretty big. Liverpool. So one of my son's friends is big into Liverpool, and so he was like, "Yeah, you need to be like Liverpool, fanatic with me." And he was just like, "Sure." So all the time he was like, "Oh yeah, we got this place last year in the football league," and I was like, "You worked hard for that, didn't you?" And he was like, "Dad." Just saying. All right. 4. Let f be a function such that f of n plus 1 is equal to 1 minus f of n squared for all n belonging to positive integers, technically plus 0. Which of the following correctly expresses f of n plus 2 in terms of f of n? So this is an interesting question. I haven't seen one like this before. Not really. Okay, so A is going to be 2 f of n squared. B is 2 f of n squared. Nope, wrong. 2 times f of n minus f of n squared. C is 2 f of n plus f of n squared. I mean, this would be a bit of a challenge to try to put this on Desmos. 2 f of n squared minus f of n to the 4th and E is 2 f of n squared plus f of n to the 4th. All right, so since we know that f of n plus 1 is equal to 1 minus f of n squared, we can say that f of n plus 1 parentheses plus 1, or f of n plus 2, is equal to 1 minus bracket f of n plus 1 squared. So this becomes 1 minus bracket 1 minus f of n squared all squared, which is 1 minus parentheses 1 minus 2 bracket f of n squared plus f of n bracket to the fourth. So this is the 1 is going to subtract out with the 1, that makes 0, and then we get a negative going in to switch the other two signs. So this is going to be a positive 2 bracket f of n squared minus bracket f of n to the fourth. So that's actually not terribly difficult. That is D. That's a nice quick one. N's a dummy variable, so you don't think it's that hard. Right. I guess. I just think that, like, if you try to plug in just generic f, it's not going to know what to do with this. Yeah, like it doesn't know what to do with this. So there's no specific values that you can particularly plug in to get something nice. And yeah, I know I plugged it in wrong just because I was throwing in something. Right, so it didn't graph anything. So, oh well. Alright, that is f of n plus 2. And it is, in fact, selection D. Cool. Right. 5 of 25. Let f be a real valued function whose inverse is given by the equation f inverse of x is equal to x times the quantity 1 plus x squared plus parentheses 1 minus x squared. What is the value of f inverse of f of 2? Here's a widget that might work. Oh, all right. I mean... yeah. So I've got a logarithmic scale on that, which is not particularly helpful. Recurrence equation solution 2 to the n minus 1. So that could work. Okay. So in theory, right, this function is going to be this function is going to be 1-to-1. Right? It better be, so that we have a function and an inverse. It's going to work out all right. So, in theory, right, these two bits, f and f inverse, are going to undo each other. So really, what is the value of f of 2 is an equivalent question, provided that, again, it is a one-to-one function. F is a one-to-one function, and F inverse, by extension, is one-to-one. So that should mean that f of 2 is what we're looking for. So f of 2, if, right, y equals f of 2, then f inverse of y is going to be equal to 2. And then we could rename this as f of x, because why not? Because we can. Right, so this is going to say that we want to figure out when is 2 equal to x plus x cubed plus 1 minus x squared. So, subtract 2. Okay, and we get 0 is equal to x cubed minus x squared plus x minus 1. That is solvable by factoring, by grouping. We can kind of look at it and say, okay, if we take out an x squared, we're going to get x minus 1. And then we get a plus 1. And 1 times x minus 1 is the last few terms. It's equal to 0. This is now x squared plus 1 left over when you remove x minus 1 also multiplied. This stuff is going to be x equals plus or minus I, so those are not real valued solutions. You could also, because those cannot be equal to 0, because we cannot get x squared equals negative 1, you could also divide by that, and you're left over with x minus 1 equals 0, so therefore x equals 1. Really, the trick on this one, and I hesitate to use the word trick, but the important point is that we're looking at the inverse function, and we're saying, okay, we want when the function value is equal to 2, what do we get for the x value of that inverse function? So again, we could just come back here and say, okay, I want x times x minus 1 plus x, nope, 1 plus x squared, not even close. 1 plus x squared plus 1 minus x squared. Right, and then when is this equal to y equals 2? Bingo. So our particular x value that we're looking for in this case is 1. And that is what we got down here. X is equal to 1. If R is integral domain, so is R of x. As in, worried about the real valued stuff, or we were worried about fractional values? Gotcha. Right, zero product property. Okay. Didn't even list out the other possible answers. -2, -1, 1, 2, or 7. If you define F inverse as G, G is injective. I never remember what the... They should be bijective, right? Because... Oh, it doesn't have to be onto. Okay. Necessarily. Okay. So that means that F inverse, every one of its numbers is represented. And could... Oh, wait, hang on, we graphed it. Okay, it was real valued. It wasn't necessarily integral. Or, it didn't have to have integer solutions. That may not be what you're asking, actually. But, anyway. So, on the real numbers, it's going to be bijective. So we have every number accounted for in the x direction and every number accounted for in the y direction. I'm not sure I understand the notation. Negative x squared is too weak for x cubed. Change the 2 for 5. It's not objective anymore. Injective. On the integers. Yeah. But again, number 4 was the one we were caring about integer sets, and 5 was just real valued. So it didn't matter what we had. We just wanted real values. Okay, 6. Let F, G, and H the exponent. Oh. Okay, yes. Because not every... Right, it won't be one-to-one. Let f, g, and h be real valued functions defined for all positive x such that f of g of x is equal to g of h of x. If f of x is equal to x plus 1 and g of x is equal to the square root of x, what is h of x? Okay, so for all positive x, we want to be able to say that f of g is going to be equal to, this is the shell is f, and of g means that g of x is going to replace all x's. And then we also want g of h of x, which is going to be the square root of, like that. We want this to be equal to the square root of x plus 1. So, I mean, should be the square root of x plus 1 parentheses squared. Not an option. Okay, so x squared minus 1, square root of x minus 1, square root of x plus 2, x root x plus 1, or 1 plus parentheses root x plus 2 outside times the square root of x. Goodness. Do I know the Viking history of this particular town? No. Okay, so there appears to be a veil in... Wow, okay. The Vale of York, which was, roughly speaking, in this-ish area. The Norse also were not technically, well, the Norse were not technically in this area between 550 and 1100. It was mostly the Danish. And then further to the west was the Norse Kingdom of Dublin, which was actually in England, now what's now England. It's kind of fun. Just carved out a bit of the West Coast. Yeah, I mean, that's like the Vale of York hoard was a hoard of 10th century Viking coins, 617 silver, and 65 other items found near the town of Harrogate in North Yorkshire, England. That was the largest Viking hoard discovered in Britain since 1840. Or until I don't know. Identification 2007. Okay. Okay. The Anglo-Saxon Staffordshire hoard found in 2009 was larger. 4,600 items and metal fragments. Yeah, okay. Consisting of gold and silver metalwork. 5.1 kilos, goodness. So, Vale of York was... Nah, doesn't even say like how much it is total. Approximately valued at 1.08 million pounds. Now part of a... Maybe not now, but... Yeah, from 2017, so it seems like now it's included as part of a touring exhibition known as Viking Rediscover the Legend. That's kind of cool. There is a list of hoards. I mean, of course there are. Danish were vengeful. I mean... when you're getting pressed from all sides by the Vikings and the Norse, or by the Norse and the Saxons. Life is hard. Sometimes you just got to tell them all to piss off. That was a different channel. Whoops. Crusader Kings. Yeah. Okay. Couldn't defend England. I played some sort of combat flight simulator with my college roommate, and like the two of us were doing the battle for Britain against the Germans in World War II, and it was absolutely impossible. And like every time you lose, it's you lose like a portion of the map, and then you have to. It was awful. I mean, partially because we just didn't know what the hell we were doing, but. It's Dr. Gold! How you doing, everybody? Woohoo! Good evening and welcome. My name is Obi-Wan Pez, and this is N Simplex Pachinko. We are doing some GRE stuff. So right now we're looking at the Chapter 1 review questions, which cover all of pre-calculus. So... This is the math subject GRE, yes. Says math subject, I think. Okay, well, okay. Technically, it just says the math test. However, it does cover, if this goes about answering your question, it does cover number theory, abstract algebra, and additional topics, including set theory, combinatorics, probability statistics, point set topology, real and complex analysis. So, math subject, okay. Oh, good. Yes, it is not the one that starts with, like, basic algebra. Lifetime teaching? No, that is the praxis, and that is not even a lifetime. Yep, baby math. Oh. Okay, so, oh, you know what? This one, right here. Look at this. This is 1 plus 2 square roots of x plus square root of x parentheses squared. So what is that? That's 1. That's not a 1. It is 1 plus the square root of x parentheses squared, which was exactly what I was looking for in the first place. Right? I knew that this had to be that. I just forgot. There's these weird alternate forms that you could possibly shove it into in order to distract people from exactly what it was going to be. Alright, we're going to snooze this for the last time because we just got rated, so it'd be kind of rude to shove everybody into ads after they just got here. Yeah, it looked too suspicious. But you do want to just check, right, to make sure that, yes, this is actually the thing I was looking for in the first place, and not just be like, it's weird, so let's assume it's the answer. Alright, 7. What is the equation of all points in the xy plane that are equidistant from the point -1, 4 and 5, -2. Okay. So, let's just look at this real quick. We've got -1, +4, up here. And we have 5, -2 somewhere down here. Not to scale, hashtag. Now, in order to be obese for the people, not the ads, I try to be. But, of course, Twitch is not going to allow me to dismiss it anymore because, or delay it anymore because I've had my 3 for the night. Okay. Now, if we want the points which are equidistant from these 2 points, so we want, first of all, the midpoint of these 2 points, somewhere about here. But when you think about it, right, you're right, we can use any infinite isosceles triangles that use this as one of its bases, or use this as its base. So now we could also create an isosceles triangle which goes out here, or again, goes here. Those would technically be different sizes, but I think you get my meaning here, right? Any of these particular points, which then form, if we connect them, a line which will not necessarily go through the origin, so we have to keep that in mind. But this would be a good point to start with. And bonus, right? What's the relationship between these angles? It's going to be -1 plus 5 over 2. We need to find the average of the x values to get the thing that's right in the middle, and the average of the y values to get the thing that's right in the middle. 89 degrees, am I close? You're close. I see UP underscore. Thank you for the follow. We get 4 plus -2, all divided by 2. This is going to get us our midpoint. Hello, hello. I saw you in probably Dr. Gold's the other night, but also in Zach's, I think. Welcome. Yeah, we're doing all right. It's going to be 4 over 2, which is going to be 2. And this is going to be 4 plus -2 is 2, divided by 2 is 1. So now we have a point. It's 2, 1. Then we do have the relationship between these 4 angles that surround that particular point. Specifically, the line that we've got needs to go straight through. All lines are straight. Needs to go through 2, 1 at a right angle to our line between the 2 points, -1, 4 and 5, -2. It has to be at right angles. So they are perpendicular to each other, which means that the slope must be the negative reciprocal or opposite reciprocal of the slope that's here. So the slope between -1, 4 and 5, -2 is going to be m is equal to y2 minus y1, right? So let's do 4 minus -2 just because, over -1 minus 5. Ah, well. Megalomorph, good evening and welcome. Why is it called the locus of points? Like it's so many points that they darken the sky and make the villagers cower in fear like a swarm of locusts. Definitely. This is going to be 6 over -6. Ooh, look at that. That is a -1 slope. So now we want the perpendicular. loci. Doing some combinatorics right now. This is more difficult than calculus. If you have any questions, let us know, and we can take a small diversion. Ads are going to start in about 3 more minutes, unless we decide to bail and just do them ourselves. Let's see. So the perpendicular slope is going to be the opposite reciprocal of -1, which is +1. And if we go through the point 2, 1, I can already tell that that's going to be y equals x minus 1. However, let's just be rigorous about it. So here we've got y is going to be equal to, we can in fact do this as y minus 1. Right, it goes through 2, 1. So y minus 1 is equal to slope is 1 times x minus x1, x minus 2. So this is what we get for our equation. This is also y equals x minus 2 plus 1, or y equals x minus 1. So, generally speaking, that's what we're going to get. 7. Our possible answers were, oh boy. Just like last time, it doesn't give us the exact same things as we were expecting. So, C, D, E, I got 1.5 minutes. We can do this. A is 2x minus y equals 3. Okay, this has a slope of 2, so that's out. B, x minus y equals 1 is x minus 1. So, good times. C, x plus y equals 3. So our y-intercept's all wrong, and also, right, our x and y-intercepts are 3. So 3, 0 and 0, 3. Which also means that that would have a negative slope as well if we flip stuff around. So C's out. D is going to be y equals x squared. Well, we know that's wrong. Probably gave you 2023 y. Yeah, pretty close. E, x minus 2 squared plus y minus 1 squared equals 18 is a circle, which would be great if it was around 1 point. All right, ads are going to start, so we're going to take that break. And we'll see you in 3 minutes. Thank you, everybody, for coming on in. Be right back.
to Spotify than meets the ear. That's because video is taking center stage on Spotify, with over 300,000 video shows and 300 million users already watching their favorite podcast. With seamless switching between watching and listening, you can tune in anytime, anywhere. Got a show of your own? Upload your video to Spotify, turn views into fans, and monetize your passion.
Lights are red and they're sweat on your embrace. One other thing I dare. Lights are out and there's time to your embrace. There's another dare. Lights are red and there's sweat on your embrace. One other thing I dare. Lights are out and there's time to your embrace. There's another dare. One other thing I dare. Lights are out and there's time to your embrace. There's another dare.
Okay. So, what we have is something with an x squared plus a y squared in it. Which of the following best describes the graph of the following equation? The only answer that I could possibly come up with at this point would be circle. Unless I'm just wrong and it's a point or a line. So the way to do this out that you'd want to... right, this is a conic section. The way that you'd want to do this is to separate things. Make this x squared minus 2x plus y squared plus 4y is equal to negative 5. So this would be a problem, right? It would be a problem if this remains negative. The issue is... okay, I see it now. The issue is that we can't have a negative here because this should be r squared. Not factorial. This should be r squared, but it's a negative number. So, like, that's not good. So, what we want to do is complete the square. By adding in the appropriate numbers to make these x plus something, parentheses, squared, plus, parentheses, y plus something, squared. In this case, it's actually going to be x minus, but whatever. So we do know that x squared minus 2x plus 1 is x minus 1 squared. I hate that song when it does that. And here, y squared plus 4y plus 4 is y plus 2, parentheses, squared. And this is equal to, right, negative 5 plus 1 plus 4. Well, that is 0. So what structure looks like a circle but has a radius of 0? That's going to be a point. And that is E. So again, this was just going through all of the possible conic sections. A was a circle. B was a parabola. Okay, we could eliminate parabola because x and y were both squared at their highest degree. C was an ellipse. which, like, in theory, we could leave that in for a second because we do have an x squared and a y squared, but they both had equal coefficients. So an x squared and a y squared, 1 x squared and a 1 y squared are going to say, well, that's probably not an ellipse, but, you know, we'll just double check. D was a line. All right, both our x and our y would have to not have squares, but it could be a trick. Not really. Wasn't going to work. And E was a point. So again, it turned out that it was a circle, it's just that our radius ended up being 0. Right. 9. Let's see. Be the curve in the xy plane. Such that. Nope. Described by the equation x squared plus 4y squared is equal to 16. Okay, so this one, now I can tell that this is going to be an ellipse. If every point on C is replaced by the point one half x comma y, man, 1/2 x comma y, there we go. What is the area enclosed by the resulting curve? Well, I'm going to have to look back at our notes on what the area of an ellipse is. Oh. Is it just pi r squared because it's going to be a circle? There was no area formula directly in here, or at least not that I saw. We did it on stream once, so that's a little bit different. But if we replace all values with 1/2 x, so all of our x's become 1/2 x squared plus 4y squared equals 16. No, not really, because now this is 1/4 x squared. So 4y squared equals 16. So So this is x squared plus 16 y squared equals 64. Now, area of a... We did area of an ellipse. I think it was like a times b with some other factors in there. Yep. It might be one of those things they just kind of expect you to know, but that seems weird. Area of an ellipse. Pi times a times b, where a and b are the semi-major and minor axes. Yep. Okay. I think we also proved it, now that I'm saying it. We're going to divide by 64, and that's going to give us the semi-major and minor axes squared, which is going to be, in fact, right, let's get rid of that whole line and go the other way. Make this x squared over 64 plus y squared over 4 is equal to 1. So semi-major is going to be 8 horizontally, and semi-minor is going to be 2 vertically. So the area of the ellipse is going to be equal to pi times 8 times 2, which is 16 pi. Number 9. Yeah. It's the area enclosed by the resulting curve. So C, D, and E. 8, 4 pi, 16, 8 pi, and 16 pi. We said it was E, 16 pi. Right. 10. Every point on the parabola y equals square root 2x minus 1 is equidistant from the y-axis and What point? Alright, parabola and what point? Says this is going to be the focus. So, where is said focus? Bum, 10, 1/2 0, 1 0, 3/2 0, 2 0, and 5/2 0. Okay. So this is y squared equals 2x minus 1, or y squared plus 1 all over 2 is equal to x. Once you get it in form like that, we have focus is at P0, where this is 1/2 y squared plus 1/2 equals x. So it's shifted up 1/2, first of all. And second of all, our a value attached to our y squared is 1 over 4p, where p comma 1/2, because it's shifted up, or sorry, left, nope, right, is shifted to the right 1/2. Oh man. Yes, it's shifted right 1/2. Okay. So this is p plus 1/2, comma 0. Okay, so 1 over 4p is equal to 1 over 2. Therefore, 4p equals 2. P equals 1/2. So now this is going to be at 1 comma 0. B. All right. 11. We're almost there. Gonna get to the halfway point. 11. One of the foci of the hyperbola. Nope. Y squared is equal to parentheses x over a squared plus 1 is at the point 0 comma root 2. Find a. And no, you're not allowed to say there it is. Alright, this is 1 over 2 root 2. B is 1 over root 2. C is 1/2. D is 1, and E is root 3. Okay. Foci of a parabola. No. Foci of a hyperbola are at plus or minus C, where C is equal to Cool. A squared plus b squared, where a squared and b squared are the denominators of x and y in whichever order they are. Doesn't really matter. So we have y squared minus x over a parentheses squared is equal to 1. So y squared over b squared, b is 1, minus x squared over a squared equals 1. I mean, it should just be at 0 negative root 2, but no, that's not an option. Never mind. Oh. Right, what's A? Oi. Okay. C is going to be the appropriate... Yeah, okay. Right. Okay. Right, C is equal to plus or minus root 2. Where C is equal to plus or minus square root of a squared plus b squared. We don't know what a is, technically. We do know that C is going to be plus or minus root 2, which is equal to then a squared plus b is 1. So this means that 2 is going to be equal to a squared plus 1, and so a is equal to 1. Yeah. Which is answer D. Which one of the following polynomials P of x has the property that root 3 minus root 2 is a root of the equation of the equation P of x equals 0. So A, B, C, D, E. A is 2x squared plus 6x plus 3. B, x cubed minus 2x plus 6. C, x to the 4th plus 2x squared minus 3. D, x to the 4th minus 10x squared plus 1. E, x to the 4th minus 5x squared plus 6. Okay, so this would be onerous to go through and say, okay, this thing is equal to 0, this thing is equal to 0, this thing is equal to 0, and try and figure out which one of these has root 3 minus root 2 as one of its solutions. So just looking at it, right, is there a way that we can easily say No, right? That there is something that we could just dismiss immediately. I think our quadratics are going to be able to be dismissed because when we do this, we're going to get a solution that's b plus or minus the square root of yada yada over 2a. So this term here, right, is going to be 6 over twice 2. It's a rational number. And here, these are both irrational numbers. So I don't think quadratics are going to do it. If you look for something that's easily factorizable, right, this one can break into x squared plus 3, x squared minus 1. This one can break into x squared, so they have to have the same sign, and they add up to 5, and are multiples, factors of 6. So x squared minus 2, x squared minus 3. So this is an interesting case, but this isn't going to work either. So this is going to say that x is equal to plus or minus root 2, and this is x is equal to plus or minus root 3. Those are separate from each other. They're not entangled with this, root 3 minus root 2. So, like, this is not going to work. This one is also not going to work because we have an x squared plus 3, so that's x equals plus or minus I root 3, and this one x is equal to plus or minus 1. So we don't have any viable solutions here for A or for C or for E. So then we've got something with D, which would need to be of quadratic form, because here you've got x to the 4th minus 10x squared plus 1. You're decreasing by exponents of 2, right? Degrees of 2 every time. So this one's not really factorizable because we can't get factors of 1 that add up to 10. But in theory, we've got something we might be able to work with here. Right? This is going to get us that x squared is equal to some other values. Negative b. So positive, oops, it's supposed to be a negative 6. It's all right. Didn't matter. This is going to be a positive 10 plus or minus square root of b squared is 100 minus 4ac is just going to be 4 all over 2a is just 2, so x squared is equal to 5 plus or minus root 96, which means that x is going to be plus or minus the square root of 5 plus or minus root 96. It seems unlikely that this will end up as our solution. Now, do I want to do this? No, not really. Right? What I'm more likely to do in a test environment is just plug stuff into a calculator and graph it. Because again, it's just easier. So here we want, let's just prove it, right? 2x squared plus 6x. 2x squared plus 6x plus 3. So first of all, root 3 minus root 2. right, is like 1.7 minus 1.4 should be like 0.3, give or take. It's something small and positive. So here we look at 2x squared plus 6x plus 3, and both of those roots are negative. So that doesn't help, right? That one's out. X cubed minus 2x plus 6. Nope. Plus 6. Okay. Again, we only have a negative square, or a negative root over here, and it's negative 2. Again, root 3 minus root 2 should be small and positive. So that doesn't work at all. So that's out. X to the fourth, 2x squared minus 3. Plus 2x squared minus 3. Right? 1 comma 0. Yep, root 3 minus root 2 is not 1. So that doesn't work either. Let's just double check, right? Right, I said that that was going to get us a plus or minus 1, so. Okay, so that doesn't work either. 1, negative 10, 1. Hey, there's a number that is both small and positive. So I think, did I cross that out? I didn't really. Yeah, I just said that this was going to get this weird form, and I didn't think it was going to work, but shows what I know, right? We get this value that is the root of 96 is roughly 10, right? It's just under 10. And then here, this is going to be 5 minus 10 is going to be negative 5-ish. And so that's going to be the square root of negative 5. That gets us imaginary solutions again. And then 5 plus about 10 is 15. Square root is 4. So that comes out to be, yeah. Did I mess up somewhere? Oh, over 2. Yes, I did. Right. So root 96 is just under 10. Divided by 2 is just under 5. So 5 minus something that's just under 5 is going to be a very small number. Take the square root, and it actually gets a little bit bigger. So that actually worked out pretty well. Right? 5 minus, it is the positive version of the square root of 5 minus root 96 over 2. Root 96 does have a factor of 4 which can come out, which is going to be a 24 left over. To root 24 over 2. Yeah. So x is equal to the positive version of the square root of 5 minus the square root of 24, which is going to be equal to, allegedly, root 3 minus root 2. That doesn't seem likely. However, turns out, right, when we If we were to square both sides of this, right, this ends up with the squared version of this is going to be 5 minus root 24. And over here, the square of that is going to be 9 minus twice root 6 plus negative square root of 2 squared. Is 2. Sorry, that's the square root of 9. It's 3. And oh, wouldn't you know, square root of 24, you could take a 4 out again, so that's 2 root 6. Right, and that's going to be the same. 3 plus 2 is 5, negative 2 root 6. So it turns out that 5 minus 2 root 6 is the same number. Oh, no, wait, hang on. Square root of 5 minus 2 root 6 is the same number as root 3 minus root 2. It's a little bizarre, but it ends up working out that way. So that is D. Again, how are we doing it? Plug it into Desmos, plug it into your graphing calculator, and just double check that, yeah, this does actually work. Last one, just to check for completeness sake. Okay, so 1, negative 5, positive 6. Right. And then this one has zeros at root 2 and root 3 individually, but not combined together. So that doesn't work either. This is the only candidate left. X to the 4th minus 10x squared plus 1. Okay, that's the first 12 questions on the Unit 1 review. We will cover the last section of the Unit 1 review, or Chapter 1 review. The other 13 questions, hopefully next time. And we'll see how it all goes. So, I would like to go find somebody, preferably who's doing something educational-ish. Hey, Penn Center's doing blueprints. Not quite educational, but I did finish Inscription the other day. Wow. And I gotta say, that was a pretty awesome game. Alright, let's go see Penn Center. Let's go look at blueprints. If you don't want to be spoiled on blueprints, I recommend going there anyway and then hitting the mute on the tab button. Because that works. It'll still benefit Penn and his... it'll benefit his stream, and you won't have to get spoiled. So, see you all later. I will be back on Wednesday for more math stuff, and possibly tomorrow for gamey type stuff if I feel like it. It kind of depends on how we're doing. So, I will see you all later, and I hope you have a good rest of your night, good rest of your week. My name is Obi-Wan Pez. This is N Simplex Pachinko. See you next time.